Greetings, fellow cubers. So the one I'm going to be talking about today is this little item, the 3-layer pentahedron. I think if you were going to describe it, the concept is, what would a Rubik's Cube be like if it only had 5 sides? And it's the only non-Platonic solid in my collection. Everything else I have is either a 4, 6, 8, 12, or 20-sided regular polyhedron. This one is not. So let's just interrogate this puzzle a little bit before we get started on the solve. So the top and bottom do not have centers. Okay, they have corners and edges, but no centers. There's only one middle layer versus, like, a Rubik's Cube. The equator, you can turn it, and a different layer becomes the middle layer. On this, there's only one. You can't just turn it so it swaps out. The sides turn 180 degrees. Okay, so there are no 90-degree turns. I can't turn it this way. It looks like maybe it should be able to, but no, I can't turn it. So these R moves, and if you want to do L moves, they're limited to 180-degree turns. And then the top and bottom are limited to 120-degree turns. So there's no shape shifting where it becomes a different shape. You turn it halfway. But let's think about that for a minute. What does that mean? That severely limits the number of possible moves on this. So say you're going to do an R move or an R prime. Those are both 180-degree turns. Those both put you in the same state. So there's big R and there's little r. Big R means you turn it with the edges in the middle. You turn it around the edges. Little r just means you turn it around the corner instead of the edge. I don't use the little r move, but some solutions I've seen do. But it's equivalent. Little r, it's equivalent to like an L move. So and then flipping the puzzle. Then the top and bottom, they move by 120 degrees. Okay. So 180-degree turns. So what that means is there's only a U move and a U prime move. Okay, there's no 2U, like U2 would be the same as U prime. And again, so in an R2, that would be the same as getting you back to the same state. So there's no difference between R and R prime, okay, and there's no R2, and there's no U2, there's just U and U prime. So that severely limits the number of possible moves compared to a Rubik's Cube. I would say if you want to get a puzzle that you want to play with, you want to figure out all the commutators yourself, this has a more severely restricted set of possible moves than the Rubik's Cube. So this might be the one to start with. I actually played with this a little bit before looking up the solution and solving it, and I still use a commutator or two that I learned from that. I found some that weren't useful, and I found some that were, and I eventually figured out, yeah, there's a more efficient way to solve it. But yeah, if you want to play with one before you actually look up the solve, this is probably a better one. It's not going to take you days and days to figure out. Just maybe an hour or two of playing with just what combination of R moves and U prime moves are possible. I don't know of any solutions. Maybe this is giving it away. I don't know of any solutions that use a U move and then a D move, but you could play with those too. But that still is very limited compared to what you could do on a Rubik's Cube. Okay, so I gave it a little scramble, and this one, because there are so few pieces and so few moves, you'll actually, even if you truly randomly scrambled it, you'll see 2 or 3 pieces that are together. You almost have to non-randomly scramble it to get something that looks random, because sometimes randomness looks not random. Just at random, you're going to get some order, some pieces that are 2 or 3 pieces that are in place. Okay, so the first step is to solve these center edges. I want to align them. Okay, and I'm going to do that. You can do big R moves, which rotate again around the edges. But sorry, the top and bottom edges. The big R move rotates around the middle centers. The little R move rotates around the middle edges. So I'm going to do that. I'm going to say, okay, green needs to go next to green. I'm going to flip. Okay, is this one okay? Nope, I need red next to red. I'm going to flip. Okay, so my centers aren't solved, but my edges are. That's the first start. Okay, so with the center edges in place, my next move is going to be to rotate the middle centers. And to do that, there's a very easy algorithm. I'm just going to do R, M, R, M, R, M, R. Okay, so, I didn't write it down, but that's an easy algorithm to memorize. It's just alternating versions of R and M, and it'll just eventually go into place. If you look, say, like, I think I went clockwise around the puzzle. So for that, I'm going to rotate the center in the direction that the centers need to go. Sorry, I'm going to rotate the equator in the direction that the centers need to go. So green was here, green moved this way. If you think about it, it's 4 R moves and 4 middle slice moves. And if you think about where the pieces are going, okay, so every piece goes around the puzzle, every center goes around the puzzle once, and then goes 1 extra space. Okay, so rotating it this way 4 times is going to move each center 1 position clockwise. And then if you think about what's happening to the edges, if I do combinations of R moves and slice moves, this piece always gets moved back 1 and then forward 1, so it gets a net movement of 0. Every other piece moves a total of 6 spaces. You can just do the algorithm on your own and figure that out, prove it to yourself. But if I do that, I keep doing that. So the middle edges will become salt again. Okay, and every piece is again moved. Sorry, every middle center has moved 1 piece clockwise. Okay, so let's reverse that. I was doing something for demonstration purposes and put the centers 1 rotation clockwise to where they want to be, to where I want them to be. So I'm just going to do that algorithm again. I'm going to rotate the right, but I'm instead going to move the middle anti-clockwise, relative to the top. Yeah, it's ambiguous on the middle slice whether you're rotating it clockwise or anti-clockwise. Okay, so check that out. Center is solved. The next thing we're going to do is just detect. It's just detection. Okay, we're going to detect which side is the top and bottom. So which layer is the yellow layer and which layer is the white layer. The way we do that, so these edges, these center edges are fixed in place. What I need to do is figure out which of these top and bottom corners match the coloration of the edges, okay? So I can line up, I can tell that this top is going to be white here, and the bottom is going to be yellow. Top and bottom flip if you flip the cube, obviously, but I know the orientation of the puzzle based on this, okay? I'm not going to do the corners. I'm first going to do the top and bottom edges, but I'm just using the corners for detection. Okay. So, and I can tell, likewise, I can put a yellow corner, the red and blue, with the red and blue center edge, and it doesn't match. So you have a situation where none of them line up because maybe all of these were yellow. It's still obvious. It's still obvious that these are all on the wrong layer and that they go on the bottom. Okay. So that's detection. The next step is going to be getting these top and bottom edges above their appropriate center. Okay. So here we are. So we decided in the last minute that this is going to be the white layer because the corner matches the center edge. So my white, I want to get these white edges above their appropriate centers. Okay. So let me look down in the bottom layer. Like I know I'm gonna have to actually move these white edges down because they're not above the appropriate center. In this case, I can actually turn and get these here. So blue was already in the top layer, and it was next to green. They're in the right order. So I just need to get red. Red is in the bottom. So I can turn it up like this, but then these center edges are flipped. Now my center edges don't match anymore. So I can't do that. I need to move this out of the way, then rotate, then move it in, and then move it up. Okay. So that move, it only touches the edge, and it moves some edges on the bottom, but we don't care. It moves some of the top corners and bottom corners, but we don't care about that either, because that's the next step. We'll figure out where these corners go, and we have an algorithm now to put those into place. Okay, so what I've done so far is I correctly placed the top center, the white centers. Okay, I'm gonna make white my bottom layer now, and then I'm gonna start placing the white centers. Okay, my edges are in place, and I have an algorithm here that just moves a corner, and the way it moves it from the back, the top back, to the bottom front. If I do this algorithm, and I don't care where any of the other pieces move, it doesn't move my bottom edges. I don't know how it moves the top corners, but let's just put that into action. What I'm going to do, since I have a white, this green and red white corner on top, I'm going to place that first. It's going to go here, so I need to move it to the back top, okay? And then it's going to come here when I do this algorithm. It's going to kick this one up to the top, and then that'll be good because it's going to allow me to solve this one next. When this one is in the top, I can do the same algorithm and place that here. I've got this blue-green white center. And it's in the wrong spot. It's oriented wrong relative to this, but that's okay. It's going to move out of place, and it will be where I need it. Okay, so the algorithm, again, I'm going to move the back top to the front bottom. It's R, U, R, U prime, R, U prime, R, U, R, U prime. Okay, so one more R. Okay. So did that fulfill its promise? Yeah. Okay. So this one was solved already. This one is now in place, and this one's on the top. So let's do it. The algorithm is written. It's missing one R. The manual that I saw, for some reason had alternating R's and R primes. There's no difference between R and R prime, so I don't know why it was written that way. It sounds like a mistake. Okay. So again, I've got my green, blue, and white corner and the top back. It's going to come to the front bottom. Okay, so R U prime, R U prime, R U prime, and R. It doesn't matter that I left off that R. It's kind of obvious that this needs to flip, and then this is solved. So the next thing we got the cube into this state. So the middle and the white layer are solved. And again, I'm going to put my solved layer on the bottom, and we're going to fix the top. This part's really easy. So the first thing I'm going to do is I'm going to align the centers, and that's easy. You're not going to get a parity here where like one is correct and the other two are swapped. Like that's never going to happen. That's impossible. If that happens on your cube, probably someone popped out a piece and put it in wrong. So here we are. We're almost solved. The same thing I just said about the center, the top, and the last layer edges not having any parity. Same is also true of the corners. They're in the correct order. So if you look at this, blue and blue are together, red and red are together, green and green are together. Okay, so they're correct relative to each other. They just need to be rotated. Okay, and so we have two algorithms, one for rotating clockwise and one for rotating anti-clockwise. Okay, and this is the algorithm. And the way you can think of it, you can memorize this easily. Like it's RU, 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 and then there's an odd RU prime, and then RU, RU, RU. So if you're doing the U move, that's going to rotate your last layer corners clockwise. It's going to rotate them in the direction that you're turning it. If it's U prime, the second one with the odd U in the middle, but it's mostly U prime moves, you're rotating it in the direction, again, in the direction that you want your centers to move. Okay, so looking at this, I want my red and blue centers to move anti-clockwise. So I'm going to do R, U prime, R, prime, R, U prime, R, U, prime, prime. It looks almost solved. One last R, and then completely solved. That's it. Congratulations.